Assalamualaikum, Siddiq. Can you hear me? All right. Okay, so I think we are only two right now. I think the rest of your friend already have the join the session that I have from 3 to 5 just now. But it's okay. I will still address things that I have to address for this session. Is that okay for you? If you want to on your mic, it's okay because if you have any question, okay, you can just stop me. Right? I've already also have start with the recording. Okay, so right. So I will start for this session. Where for this session I will try to cover tutorial 11, also part of lab 9 basically. Okay, so in lab 9, we will see later on what we call IPv6 setting. Okay, and with respect to that, for the lab itself, it will prolong for 2 sessions. Basically, we will only cover up to question 2.2. Okay, and then the rest 2.3 and the rest we will actually cover that next week. Okay, so this lab will have 2 session itself. Okay, but that will after I've covered tutorial 11. Okay, so let's look into tutorial 11 itself. Please stop me, or if you have any question, just give a shout and I will try to address your question. Okay, I won't able to see on the chat. Okay, so if you have question, please use your mic when I'm presenting right now. Okay. So, but before we start, I just want to make sure that you already done your teaching evaluation exercise, okay? Because that's an important part of our process to have a continuous improvement. I think yes, we on the lecture we already have a very a valid a number of participants, which consist of 30% and above. But I think for like tutorial, perhaps some of the tutorial session haven't done that. So I urge you, Sadiq, to actually also do the teaching evaluation. But if you have done that, thank you very much that for your cooperation. Okay. All right. To start the tutorial itself, so there I think in tutorial 11 here, there are few only 5 questions altogether. Okay, the first question with respect to UDP messages before exchange data. With respect to UDP, this is what they call a transport layer protocol, or is basically on the transport layer. And with respect to UDP, there's another main contender of protocol that you use or that we use in the sense that we use a reliable one, which is called TCP. Okay, so if you can relate to the TCP IP architecture itself, okay, so the term TCP is actually using the TCP control or TCP protocol in the transport layer, then use IP in the network layer. Okay, so that considered as a reliable protocol. So the term TCP IP, what they call it, networking or layering. Okay, so basically based on the transport layer TCP and the network layer IP lah. Okay, so there are 2 main protocol, with the one TCP and the other one UDP. So we are now trying to discuss on UDP. So in UDP, basically this is a reliable protocol, what we call connectionless. Then it's very simple, not much header, doesn't need to have much processes and so forth. Okay, so it's a simple messages that you exchange basically between routers or you can do your broadcasting using this UDP. So the exchange of data is very simple. So this question saying that do you need to do some setup or you need to exchange some other messages before you start sending data? The answer is no, because UDP itself is kind of like using ping, for instance. It doesn't really needs to have this connection oriented, because UDP is a connectionless, and by that it means that either the receiver receive the packet with error or without error, or even if the receiver didn't receive the packet, the sender actually doesn't care. So that is what we can say about UDP lah. Okay. So the answer for this is no lah. But you can further explain. It's a connectionless. No need to have control messages. You can directly send the data. Okay. It's low latency and minimal overhead. There's no built-in mechanism for connection establishment or error recovery. Okay, as mentioned just now, it doesn't need to actually identify either is received and with error or not. Okay. And then simplicity at the cost of potential issue. So basically, it's very simple, but it doesn't really what they call it, address specific issues like need to have reliable, errorness, and so forth. Okay, so it doesn't have to be there. Okay, and not either for scenarios requiring reliable and order data delivery. Okay, so this can be done using TCP, right? So UDP is a connectionless and it is what we call unreliable protocol. Okay, so it can, for instance, you use ping and this is actually using UDP protocol. Okay, that moving on. Question number 2, calculate the size of the largest possible UDP message. Okay, the entire UDP message must fit. The hint is that the entire UDP message must fit in an IP datagram. Okay, so it start with basically you need to identify what's the size of the IP datagram. Okay, it's actually 16-bit. So the packet itself is stretched from 0 to 65.535 bytes. Okay, which is the size of your IP packet size. Okay, and the IP itself, okay, has some header. Okay, the very basic without including any option is where you need to have 20 bytes altogether, plus another 8 bytes for your UDP. Okay, so this diagram on top here represent the size of your UDP. Okay, this is the diagram A. Diagram B represent the header itself. Okay, so the header format. So for the header for your UDP is using 8 bytes in total. So that's why here, if you want to know what's the maximum size of your UDP, which is the data over here, message is equals to the size of your IP packet. Okay, and then minus by the two header, which is the IP header and the UDP header. Okay, so you have 65,507. Okay, and if you look at this UDP, the information that attached to the UDP datagram, user datagram itself is only few information like source port number, destination port number, total length, and possible of checksum. Okay, so it doesn't need to have much header compared to TCP. So you will see that in TCP you have some other additional header. For instance, you have the sequential numbering and so forth. Right. So moving on, question number 3, what are the techniques or mechanism applied by TCP protocol? So in a TCP protocol, basically you need to implement multiple techniques. Okay, but basically you see that you need to have some sequential information, and then you need to do like error recovery, flow control, then you need to also use signing protocol and so forth. Okay, so you can also refer to your notes. Basically, the TCP is a connection-oriented, reliable protocol, and with that, there are a handshake lah between you can start delivering your data. This can be an example, for instance, when you have your voice call or your video call through your phone, right? So before you start to talk or through voice or through your video, so what you need to do is that you have to make connection, right? Or you have to call the number itself, okay? Or dial. So the dial is the process of connection establishment lah. So why do you need this? Because you want to make sure that we can talk to that person in real time, right? So in real time, you have to make connection first, okay? And then the receiver actually will acknowledge that they are ready to have this talk, okay? And then you can start the data transfer, okay? So then you can able to talk, okay, and do some conversation or whatsoever meeting or whatsoever lah. And then after the rest, after the conversation, basically you have to actually disconnect, right? So tear down the path itself, okay? So in packet switching, basically we are talking about packet switching. We are connected to all the device physically, okay? Your devices can be connected to router, switch, and so forth. And you have some intermediate switches, right? That is when we say that it's connected physically. But when you start to do end-to-end communication, okay, so you have what we call virtual path, means that they will have some path that they have to what they call it to pass through. Okay, so this path is basically start with the connection setup. Okay, when you start the connection setup, so basically you have to define what are the path that you have to go through on the packet switching network itself. Okay, and this is what we call virtual path. Okay, so you have a virtual path whenever that you want to have this connection. So whenever that you already done with the connection, then you have to disconnect this virtual path. And then the next thing is that TCP/IP is using what we call sliding windows protocol. Okay, the idea of sliding windows protocol is that when you send a packet of, say that packet number 1, packet number 2, packet number 3, packet number 4, packet number 5, basically with the sliding windows protocol that you can send multiple packet and then you can acknowledge only one, okay, acknowledgement which is cumulative. Okay, what does it mean? It means that when you send packet number 1, packet number 2, 3, 4, and 5, okay, so when the receiver receive it, okay, it will acknowledge that it needs packet number 6. Okay, so in sliding window protocol, you can see that the acknowledgement is acknowledging what is the next packet that is wanted to receive. Okay, but there are variation in this sliding windows protocol. For instance, here you have the GBN, go back N, and also selective repeat. So in go back N, what does it mean is that you send packet 1, 2, 3, 4, 5, okay, and then on packet number 4, it doesn't being received properly by the receiver. Okay, so what the sender will have to do is that it has to send the subsequent packet also. Okay, so although packet number 5 received by the receiver, but the sender have to actually resend back packet number 4, and also packet number 5, right? Whereas for selective repeats, you send everything, but you left or miss packet number 4. Okay, so you have to only send this. That is what it says is a selective repeat. Okay, so that's the difference between GBN and selective repeat. Okay, so the other things that they need to also address in TCP is that you need to use flow control. You need to have error control. So basically, the flow control is when you wanted to say to the sender by saying that, oh, please wait because we already have a very difficult task to process. Okay, for instance, when you have a high traffic, so the receiver can actually communicate to the sender by saying that it's either you stop it or perhaps you delay the packet or you slow down the generation of your packet. Okay, so that is flow control. Whereas for error control is where you have to identify if there's an error based on the parity check, either using checksum or CRC. Okay, so if possible, we don't want it to be resent. Okay, so if you can actually correct it at the receiver side, so that will be much better. Okay, and the next one is that you can also, you need to have this sequencing to handle duplicates or out of the delivery. So in this mechanism, okay, sequencing means that if you receive a packet from the application layer or say data from the application layer, and this information or this data is too big to be fit into this IP datagram, okay, for a single IP datagram. So what you need to do is that you have to put it into small pieces, okay. They call it chunk, okay, and then you can fit one message into one IP packet, okay, the second message into the next IP packet, and so forth. So the next thing that you need to do is that you have to indicate the sequence, okay. So the first one is sequence number 1, then sequence number 2, sequence number 3, and so forth, okay. So at the receiver part, okay, so there's a possibility because of the network, okay, and because of the packet generation, because of any errorness, okay, the packet can either receive with out of order, or it can have a duplicate, or perhaps it doesn't being received at all, okay. So that's with this sequencing and this implementation, what the sender and receiver needs to add is that you need to have some buffer and also the process to handle this duplication or out of order packet. Okay, so you need to have a buffer. Okay, so the sender will send packet 1, 2, 3, then 4 is missing, then you receive 5. Okay, so basically it need to save on the buffer. Okay, and it will request for the packet number 4 to be resent. Okay, so when it received the packet number 4, then it needs to reorder, because now it received packet 1, 2, 3, 5, okay, then 4. So it needs to reschedule or reorder this based on the sequence itself lah. Okay, so you need to have much more processing. Okay, and then you can retransmit. Okay, you can also do you need to avoid replay. Okay, you have done the flow control, and you need to avoid congestion. So these are some TCP features that perhaps need to be addressed before you can deliver this TCP as compared to use UDP lah. And then related question, explain how TCP handle packet loss. So basically it's a combination lah, where you can see that when there's a packet loss, one of the disadvantage is that you have to retransmit. Okay, so with retransmit, it means that you are having slower respond to your application itself. Okay, so this can be seen like when you are browsing or when you are playing your YouTube application itself. Okay, so sometimes you will see that it buffer or it doesn't receive properly. Okay, and you have to kind of stagger or whatsoever, right? So but there's also some mechanism that you can like you buffer that or you play the actual data after you have received multiple packages. Okay, so that is where the system or the YouTube application handles this problem. But you will see that there's a packet slow. Okay, the receiving is a bit slow. Okay, but it's a combination that we when we talk about this if we have this loss of packet and how it is being handled. So you can see that it can use what we call acknowledgement. Okay, when you send the packet, then receiver will be acknowledged. So that is one of the thing that makes the data delivery is a reliable data transfer, because you know that it received by the receiver, or else it will give you negative acknowledgement. And then if there's something errorness happens, so you can retransmit. Okay, you use the selective repeat and also go back end to acknowledge that cumulatively. Okay, fast retransmit using sliding window and flow control. You use also congestion control, and you can use this what we call TTL, okay, time to live, where when you send the packet, okay, and it will start to count to some maximum time before it needs to retransmit. Okay, so there's a TTL that respond to this packet transmission. Okay, so this is how it deliver when you have this packet error or packet loss itself, right? And the last question, basically here it says that you have the flow control mechanism, and also you have the sliding window size, okay, based on the receive window and congestion window size, okay. You need to explain what does it mean by receive window and this congestion window. And second part of the sub question of this of question number 5 is that if the receiver window is 15,000 and the congestion window is 5,000, what should be the sliding window size or used for this flow control? Okay, so definition first is that for the receiver window reflects the number of bytes that a receiver can accept, whereas the congestion window reflects the number of bytes that can be sent depend on the network condition. So basically, the congestion window is being implemented at the sending side, and the receiver window is being implemented at the receiving side. Okay, so out of this, basically you need to find what is the lowest value between these two. Okay, so if the send congestion window is too high, the receiving window won't be able to deliver, right? So you see that the window size is the lower value of the receiver and the congestion window. Okay, thus the window size is 5,000. Okay, so that would be that relates to your tutorial 11 itself, right? So we wanted to go to the lab 9 itself, okay, with respect to IPv6. But before we enter the lab discussion, just some recaps with respect to IPv6. Okay, so it's IPv6 that you have these different types of transfer. Okay, so it's when you have a point-to-point, we call it unicast. When we have a point to selective devices, we call it multicast. Okay, and when you have a point to a group of devices, but it is nearest to the one that you want to send. Okay, so this is what we call anycast. Okay, and in IPv4 we have another one is called broadcast, but in IPv6, okay, you don't have this broadcast method, right? So this function is currently being taken over by the multicast function. Okay. And in IPv6 also, similar to IPv4, okay, where in IPv4 we have 4 things that we need to consider on this network portion and the host portion. Basically, you have the classless, classful addresses, okay, where in classful addresses you have class A, right? So in class A, you are using the first 8 octets to represent the network portion, and the last 24 octet or the third or the third octet, okay, used for the host portion. And then you have the class B, okay, where you have 2 octets that represent the host, the network, and another octet represent the host. And then you have the class C, where you have this first third 3 octets, okay, that represent the host, the network, and 1 octet represent the host. Okay, and then we also have this what we call CIDR, the classless identifier, okay, for your IP addressing, where you say that it will be based on that octet, but basically you can borrow another bits to have your network be segmented, okay, and the bits represent what we call the network subnet, okay, or the subnetting number or subnetting information, okay. So same goes for IPv6, but in IPv6 they already say that out of the 128 bit, 64, which is half of the bits, is being assigned as a network portion. Another 64 is assigned for the host portion, okay. But it can actually also say that you don't need to have the whole segmented like that, okay. So say that for point to point, okay, so you can actually suggest that 112-bit network and 16-bit host. Okay, so that is another example. Okay. And later on in the lab also, we'll see that the MAC address can be used as part of the IPv6, what we call link local address. Okay, so if say that here your MAC address is 00902717FC0F, okay, so here you see that is a 6 hexstat. Okay, this is hexadecimal. So you need to match with your what they call it 8 hexstat for your network in IPv6. Okay, so now you can see that half of the MAC address over here, 17FC0F, is being separated, and the other half, which is on the right hand side, is being separated. And in between, you add the FFFE. Okay, and this will become a new address. Okay, that basically now you can also need to do this. Okay, where the 7 left mode bit. Okay, so out of say that from 00, this is in binary. So 00000000 U0. Okay, so basically this is where you need to add change the 7-bit to 1, right? So with respect to this, okay, so now instead of the first section over here is 00, now it's become 02. Okay, and then the rest will follow lah. Okay, so this is what we call EUI 64 addressing. Okay, so use EUI 64 addressing. Okay, so EUI 64 is basically using the MAC address of that device to become part partial of your IPv6 addresses. Okay, and then you can see that IPv6 is actually defining what we call unicast address, okay, which is a single interface. So later we'll need to do this unicast assignment. Okay, and in IPv6 also, you will see that it has some other addresses. Okay, we call it link local address. Okay, and also we have this loopback address, all node multicast address, and so forth. Okay, and basically the basis of it is that for your IPv6, you will have what we call global unicast address and this link local address. So later we'll see that each interface or each device will have these 2 different addresses. Okay. Okay. Interface identifier. All right. Representation of the address. Okay. So in IPv6, it's 1 to 8 bits. That being used, right? And the sequence of the 8 groups of 4 hex digital, 16-bit each, separate by columns. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8. This is what we call hexstat. Okay, so this 3F actually is equals to or basically if this 3, okay, is actually represent 3 bits 4 bits, 1 2 3 4 x bit. Okay, and then the F also have another 4 bits. Okay, so in total, if you have in your hexadecimal here, you have 16 bit altogether in a single hexstat over here, right? So 16, if you times by 8, you get 1 to 8 itself. Okay, so this is how you can see the IP address in IPv6. So you have to define what is your unicast address. So this one is the unicast addresses, and you have the specific address with all zeros. Use a source address during initialization, meaning that at the beginning you will have this slash 64 during the initialization means that you don't have any address yet. Okay. Then you have this loopback address. Okay. Colon 1. Okay. Same as 127.0.0.1 in IPv4. And then you have this link local address that actually being addressed where it starts with FE80. Okay, so later we'll see that the link local address FE80 will actually represent the address for that specific network. Okay, and it can communicate with any of that within the specific network, right? And then for the unicast global address, okay, so you use IPv6 address, the 128 long, okay, and the prefix length, okay. So for instance, you can start and it will start with 2000, or for here you can say that it's 2001 0468 and the rest is 0/35. So this is the prefix length. So this prefix length actually represent how many bits that being used to represent the network. Okay. So here you can see that you have the same address, but you have different prefix. Okay. So what does it represent? So say that these are the number of bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 32 lah. Here is 32. But basically, this can prolong up to 35 that represent the network. Okay, whereas here 32 means that this will actually represent the network itself. Okay, so it looks the same except that the prefix length would be different. Okay, and if you look in details, okay, the allocation of the prefix basically will have a very important impact, and basically you have to be careful lah. That's the thing, right? So when it says that it say that /48 over here, okay, same as IPv4, means that the network side, okay, you can stretch up to 48. So here, this part is basically the 48th of your bits, okay, and then this need to be maintained, and this is the start of your network address where the rest of it is 0, and this part will be maintained and the rest of it will be 1. Okay, so your network will stretch from these zeros until these all ones. Okay, but since you are playing with your hexadecimal over here, so now in hexadecimal you need to have 4 bits, right? So this one 0010 is your 2 over here, then 0 here is actually this 2, a single hexadecimal number, then this one represents zeros, okay, and then so forth until here, okay, 1000 is actually your 8, right? But after that, okay, the next hexadecimal over here that represent this 8 bit, okay, since it can move or it can change from 0 to all ones, okay, from all zeros to all one, so your network will start with 000, and part of it is here, so you have to include this is 0, but here you can see that 0001, okay, so with respect to that is 1, start from 1, okay, it's not that this become F, right? Okay, so needs to be careful on this, okay. And it will play much more when you have different prefix itself, okay. So again here you can see that you have to be careful over here, right? Because this one and this one will have a different meaning. Okay, so here perhaps you can say that this is all zeros, whereas here is actually start from 1, then you have F. So this one is F. The rest is 0. So it will be much what they call we say that need to be careful because of this representation. Okay, same goes for here. Okay, so now if you are using 40, okay, up to here, and then the rest will be need to be careful like this one F, then we start with then 00. 1F is or FF over here. Okay, so 1F So be careful on this. And when we do this configuration later on, what you need to do is that you need to use this specification that you need to identify that your IPv6 is using unicast routing. Okay, and then you have to configure your IPv6 address based on IPv6, right? So how you configure this is that IPv6, then address, and what will be the IP address in IPv6, then what is the prefix of it, okay? And then you can also do router advertisement, okay, or enable it using IPv6 ND suppress -RA, okay? This is tunneling. This is if you are using route and so forth. Okay. So now what we can do is that we can go to the packet tracer, right? And in packet tracer, what you can do now is that with respect to your lab 9 itself, okay, so you need to do this configuration. So what you need to do is that go to your packet tracer, right? So what you can start introduce two PC, right? Two PC, and then a single switch, right? Okay, so just 2960 for instance over here, right? And then you connect this. All right. Why? Okay, so now it will give you some background process. Okay, so if you look at this, okay, what you can do is that you can go into your PC2 itself over here, right? Left hand click on your PC2, go to desktop, and then to IP configuration. Okay, so you see that you have the static or automatic configuration for your IPv6. Okay, and one thing that you can identify is that your link local address is being already configured for you, okay, or it's being given to you automatically. Okay, so say that I copy this, I copy this, okay, and perhaps I wanted to go to PC3, right? So what you can do is that you can go to the desktop and go to command prompt. Okay, so I'm on your PC3, right? And you can start ping, ping whatever the address of the other PC. Okay, so I just paste, and you can see without doing any setting, okay, so it's already being connected. Okay, sorry, because I done some setting, bad setting. Now it gives me a reading or auto reading from this PC itself. Okay, but what I'm trying to say is that when you have this setup without having to do any configuration of IP, it will already give you some info, or it will give you already the link local address, okay, automatically. Okay, so you can do ping, but if you are within the same network, okay, or the same physical interface, right? So another thing that you can do is that you can also go to your one of the PC, okay, and then you can go again to the command prompt, okay, and what you can do is that type IPv6 config space/all. Okay, and this will give you some information that relates to your network itself. Okay, so if I copy these two, right, and I put it into my PowerPoint over here, right? Right, so here is my address of your physical, which is your MAC address, and also the link local address. Okay, so coming back to the EUI 64 just now, right? So if you look at this, okay, so this portion 409468. So again, you can see that this can be seen over here, 409468. And then a part of it, or perhaps in between, you see that FFFE over here. Okay, so now you can see also 0030A3, but now this 7-bit needs to become 1. Okay, so it's now changing from 0030 to 230. Okay, and A3 itself over here. And this is the host address for your link local address, whereas the start of your link local address is actually being defined as FE80, right? So with respect to this, basically your MAC address is being used to get or to be given to this link local IP address, right? Okay, so the FE80 is basically the start address for your link local address, and the host address is actually, this is your 64 bits altogether, is actually part of your physical address or your MAC address. Okay, right, so you can ping your link local address, right? Okay, you can also do IP config. Okay, so that is one thing. Then you also can assign your IP, your global unicast address. So what you can do now is that you need to assign your IP address, PC0, mine is PC2, PC1 is PC3 right now, to 2001 and then 1/64. So what you can do now is that you go to IP config over here, you start typing 2001 colon 1. Okay, and then prefix you have to also include 64 over here. Close it. Okay, and then do the same thing for PC3 over here, right? So mine would be 2001 colon now 2, and then this would be 64, right? So with respect to that, if you do the IP config just now again, okay, go to your command prompt and do the IP config, IPv6 config /all. So you can now see that there's another address that also be defined over here. Okay, copy, and I move to this. Where is my? Yeah. Okay, so Control A, Control V. Okay, so now you can see that the global unicast address for my PC2 just now is already being configured based on this static address 2001 colon 1, right? Okay, so with that, you can actually also ping, okay, using this global route, global unicast address. So ping 2001 colon, the other PC is 2. So if I ping, then you able to have a reply. Okay. All right. So with that, we have already covered this. Okay. So you can ping. You can also do IP config based on this diagram. Right. So the next part is that we want to do auto config. Okay. And you need to introduce this, right? Or perhaps we start with the setting of this interface and then use this static route that we already have. Okay, so now we need to introduce a router, right? Okay, and choose 2901 for instance. Okay, and then just put it here, right? And then you make this connection, right? Okay, so now you have to configure your router. Okay, so how do you configure your router? Basically, I can say that you can use this command to configure your router, right? So go to your router and then go to your CLI command. Okay, start with accepting no over here, and then enable, right? And then you need to do interface settings. So config, and then interface. I think the interface is gigabit internet 0/0, right? And then the IPv6 address is 2001::FE, then /64. Okay. Then type no shutdown. Just to make sure that the interface is being turned up lah. All right. So now what you can do is that you can end write memory. Okay, and then now you can see the interface by typing show IPv6 interface brief. Show IPv6 interface brief gigabit Ethernet 00 F8 0::20C:8 5.F:/FTD9:2C01 2001::F4 gigabit Ethernet 01 administratively down unassigned VLAN 1 administrative. Sorry for that. So now you can see that this information on the router, right? So you can see that for gigabit Ethernet 00, you have this IP address, which is your link local address that being assigned by the device itself. Okay, and then you have the 2001 FE. I think I did configure it differently. I think. Yeah, I did configure it as 4. It's okay. Then we have the reference here, F4. Okay, so now you see that you have configured it to F4. Okay, so you have done that part. Okay, configuring it should be FE lah, but I did configure it as F4, right? So now you want to try to ping your other network. Okay, so you can do the same thing in your packet tracer. Ping what is the PC IPv6 MAC address, IPv6 address. Okay, so ping 2001 colon. It should be double colon 2001 double colon 1. Okay, we close this again. We open it. Okay, so you ping double colon 1. Still not able to.
Unrecognized host address or protocol.
Again, ping 2001 double colon 1. Okay, so now you have a success of 100%. So meaning that you're able to ping properly lah, right? Or you can also start to ping from your PC2 over here, okay, using your common prompt, and you know the IP address is 2001 F4, right? So you can ping 2001 : F4. Okay, so it gives you a reply of your PC from your PC. Same goes if you use this lah, right? So now using this static IP, you have done this configuration, right? And you can ping, okay, and you can fill in the rest of the information that be needed for this experiment, right? Okay, then moving to 2.1 is this auto configuration, right? For auto configuration, what you need to do is that you have to release the PC1 or mine is PC2 and PC3. Rather than use static, we want to use automatic. Okay, now you can see that it's not being configured. So now you unable to get this IP address automatically, right? So you can go and start with the auto configuration using this setting. Okay, so you can go back to your router. Just now we already configured that the IP address, right? Okay, and then you can start to do this auto configure, right? Then so
Router number.
basically you have done this gigabit interface, then IPv6 enable, and also this. Okay, so you can now start again configure terminal, and then type IPv6 address auto configure, auto config. Okay, so basically you have to identify the interface first. Okay, interface gigabit 0/0, and then perhaps you can start IPv6 address auto config. Okay, so then you can end and write memory. Okay, supposedly, right? So supposedly now, when you go to your packet tracer back, where's the packet tracer? Not this one. This one. So when you go back, it should be given that this IP address IPv6 being configured automatically, but you don't see that because you miss one more thing, is that you need to define this IPv6 unicast routing. Okay, so go back to this router and then again configure configure terminal, and then you type IPv6, then you can also use question mark. Okay, so there's one command, unicast routing, right? So after this, you end and write memory. All right, so now if you go back to this PC, it's supposed that it will have this IP address being given automatically. So now you have this IP address, okay, with respect to the global unicast address, where it starts with 2001, whereas the default gateway, you have it of your router, but now this is based on your link local address. That is why you use FE80, okay? Same goes for your PC3 that I have this here. Okay, so if I change it from static to automatic, so you'll be able to have it. Okay, so it says here IPv6 request successful, right? So if you want to have this IP address, so for instance, you can go to your command prompt, do the IP config again. So do IPv6 config/all IPv6 config /all. All right. So you need to get this IP address because you cannot remember the whole IP address. So just take this from this copy here, and then you can go to your PC2 again, right? Here you can actually use the command with the ping command with respect to the IP address that we have just now, right? Okay, so now you can ping. Even if you are at the router, you can also ping. Okay, so at the router, you can also ping, and then you paste this. Okay. All right. Okay, so now you should have been successful to generate all the information that needs to be filled in here. Okay, change PC0, PC1, and router IP address to auto config. Okay, and then fill in the blank below, and you see that you have this PC0 IPv6 address, PC0 link local address, PC0 IPv6 default gateway, and so forth. Okay, so you can fill in this, and perhaps you can up to this 2.2. Then later next week we can continue. So this part is actually the EUI64, just to mention that you can get the MAC address useful for your link local address delivery lah. Okay, so that will be it, right? So now you can try this, okay, and I'll still be here. If you have any question, you can raise up, okay, by either command on the chat, or perhaps you can also make turn on your microphone and you can start to ask questions, right? So now is your chance to also do the lab inside.